thank you all for coming here today. Very good afternoon. Sorry for the initial glitches with the AV. AV is always hard. So my name is Sri. It's kind of easy to remember because it's just the first three letters of both my first name and my last name. So take that common, and then it's all easy after that. And so today I'm going to be talking about something that's very near and dear to my heart. It's a story of an infrastructure change, an infrastructure migration, something that I have been deeply involved in over the time here at Yelp, and something I've had the fortune to help shape for the better or for the worse. You ask my colleagues, they say for the worse, but hopefully went for the better. Let's get started. So my hope is that over the next 30 to 35 minutes or so, I would like to cover basically three fundamental questions. The what, which is what are the right technological investments and what are the right bets to make when you're designing your company's data infrastructure? The second question is when. When do you actually tweak something? When do you evolve something? And when do you actually rip it all apart and throw it away in favor of something completely brand new? And how do you do all of this while managing business priorities? And most importantly, how do you manage all of this while sort of taking into the delicate balance of developer happiness? So to get started, start off with a quick prologue to the story. For those of you who are not aware, Yelp is a web platform and a mobile platform dedicated to helping consumers find great local businesses nearby. So for example, if you are looking for a chocolate shop here in San Francisco, you can search on Yelp, find that great chocolate shop. If you end up eating too many chocolates and you have to go to a dentist, you can find that on Yelp as well. And if you end up having a poor experience with a dentist, you can also find a personal lawyer on Yelp. So the reason I'm saying all of this is because Yelp is not just a simple reviews website. And so we have a lot of different business artifacts. You have reviews, you have photos, you have transactions, you have ad opportunities. So really tons of different business entities that have evolved over time. And this is a really cool publicly reported metric around review growth that we have at Yelp. And it's a good proxy for how every single business entity at Yelp has evolved over time. So for example, back in 2007, we had very few reviews on the site. In 2018, we have 155 million reviews. And pretty much every business metric we look at sort of is going in that direction, which is nice, which means we all get paid and the company is healthy. But on the flip side, for someone who is on the infrastructure side, it means that the infrastructure needs to scale in order to support these growing business needs. And these infrastructure changes will need to happen today, tomorrow, the day after, and will have to continue to evolve over time. And with that premise in mind, I'd like to take you all back to the memory lane. So this is right about when I joined Yelp in 2011, 2012-ish. Yelp was a very small engineering company. We had around 100 engineers or so, and we had one single monolithic application. Yes, there will be lots of sci-fi references. And that entire monolithic application was written in Python and was supported by a MySQL backend. It worked really well for the use cases that we were supporting. The business was doing really well. Everything was really fine. But there was a time when we started to hire out our very first data analytics or data science teams. And so these folks came in, really talented people, started working with our data. And then we started hitting some real production scalability limits. And the reason was this single production database cluster was serving both production traffic as well as analytics traffic. Now, that can be problematic after a while because analytics queries are fundamentally different than production queries. In the world of tech jargons, because there are so many tech jargons that we deal with, these are called as OLAP queries, which are analytics processing queries, which typically tend to involve lots of joins, pulling together a lot of data. It's fundamentally very different from how a production use case is operated, which is centered around lookups or writes to a database. And so round about this time in 2011 or 2012, we started to really hit scaling limits on our database. And so we had to do something about this problem. And so, yay, it's decision-making time. And with every other decision, we were we had 3 options. How many of you have seen like one of those game shows where there are 3 doors, there's a lion behind one door and gifts behind the other 2? It was kind of like that. And the 3 doors that we had were build something, which is like build something from scratch that solves the current business problem that we have, or buy something off the shelf that's going to solve our problem, or do nothing at all. I actually want to take a pause here and say that do nothing is actually a pretty powerful solution to a lot of the problems out there. But in this particular case, it wasn't a good solution, because if we didn't do anything about this problem, at least 2 things would happen. Number 1, our SRE engineers and our database administrators would quit, because they would get burnt out trying to keep the database up and running for both production and analytics use cases. Number 2, our analytics team would quit because their queries are just taking forever to run and they can't do their jobs. And of course, the third thing that would happen is the business would suffer as a result. So do nothing was clearly not something we could afford to do. So we were left with 2 options. We could either build something to solve this problem, or we could buy something off the shelf to solve this problem. And so to do that, there were 3 fundamental questions that we were asking ourselves. The first question is, are there any out-of-the-box solutions available in the market that is going to work for us? And how much do they cost? Not just now, but over the period of 3 months, 6 months, a year, 3 years, and so on. And of course, can we build something better, faster, and cheaper than what's available? So what we decided to settle on back then was a combination of building something and buying something. And so there were 2 infrastructure pieces involved. One is the database solution, which is going to host your analytics queries. And the other thing is the pipeline that's going to push your data into this database solution. The database solution is what we call traditionally as data warehousing in the industry. And we really didn't want to build a data warehouse because it's complicated. And for a company like Yelp, whose expertise was to build really great products for users and data analytics, our expertise wasn't to build a database. So we decided to go with Amazon Redshift, which at that time was a pretty great product. It still is a pretty great product. It allowed us to get data into Redshift really, really quickly, really supported fast queries, fast joins, and all of that good stuff. On the flip side, we did not want to buy a pipeline off the shelf because things that were available in the market were just either too expensive or, more importantly, too inflexible. And more importantly, engineers don't want to work with enterprise things because enterprise things are bad. No, I'm just kidding. But there's definitely a lot of like flexibility challenges involved there. So we decided to build our own solution to solve the transportation or the pipeline problem. And so we settled on this mantra of buy what you can and build the rest, where what you can for us was basically a function of cost in terms of how much is it going to actually cost, and how much is it going to cost in terms of developer happiness. And I'll talk a little bit more about the cost framework later on in this presentation. So what we ended up building was this beautiful extract, transform, load system, or ETL. It's beautiful because you can make a lot of ET puns on them. So this system was entirely written in Python. It's a really cool infrastructure solution. Takes all of this data from MySQL, applies business logic, transforms it, and then pushes this data onto Amazon Redshift. So everything's working well, and the future looks bright and happy. Our data infrastructure engineers are very happy building this really cool ETL infrastructure that solves a real-world business problem. Our analytics teams are very happy now because they have a stable data warehousing platform against which they can run their queries, enabling them to make good business decisions. And in the end, the business is very happy because the above 2 things are happening. So yeah, I think that's it. End of my talk, 4 o'clock. I think time to go home, right? Well, not exactly, because this system also hit its scaling limits. It worked really well for a while, but after a certain point of time, this also stopped working. And there were 2 fundamental reasons as to why it stopped working. First, of course, is the more easier one to explain, so I'll start off with that, which is the technical scalability problem. So this was roundabout in 2013 or 14-ish. Yelp had started to acquire a couple of other companies. We brought in lots of huge data into the company. And so we were at this point where this traditional batch-based system stopped working. And one of the reasons is a batch by definition involves doing a partial or full table scan and moving this data across. And that's fine if you have a small table with a few million rows, but if you have tables that are of sizes larger than 100 million, and you have thousands of them, then the system stops to scale. But one could argue that we could do some performance optimization, make some small tweaks here and there to solve this technical problem. Yes, we could have. But the bigger challenge here was what I call organizational scalability. And to explain this concept of organizational scalability, let me sort of give you all some examples. So around about 2014, Yelp really embraced the microservice architecture, which was great for everything that microservices are good for. Developers can push code faster. You're not married to any particular technology. You can use whatever tech stack that you want to solve the business problem. But on the flip side, it was a nightmare for the data engineering team, which was the team that I was involved in, because here was one team who was responsible for piping all of the data from all of the different places into all of the different places. And when you have tens of different systems to pull data from, it becomes really hard, and your engineering team is probably just 8 or 10 engineers. And so we ended up in the situation where previously our analyst team would just have access to the data that they needed. But now they were in a situation where they had to prioritize what data they needed. So for example, let's say Yelp went into the transactions business and we have food delivery. Our analyst team comes back and says, hey, I want to look at all of this like food delivery data and try to see if we can come up with a better product. And then they come to my team, and then my team has to say, well, sorry, we don't have time to pipe this data in because your request is number 25 in the queue, and we have to tackle other ones first, which really sucks for an analytics team. So their life basically looked like this. They just stood, waited, twiddled their thumbs, and not a great space for us to be in. So a question that might be popping into your minds is like, yeah, we could add more engineers to this problem, right? Adding more engineers always solves everything. Well, the reality is that's not true for at least a couple of reasons. The first one, of course, is we are all expensive. And it's not easy to hire engineers, as you all must have experienced. And the second more important thing is these ETLs that our engineers were writing were actually very rudimentary business logic. And so no one really wants to spend their entire time, 5 days a week, 8 hours a day, making rudimentary business logic changes, like multiplying a column by 10 and so on. So it's not really motivating work for engineers who are working to build really cool infrastructure platforms. So we were in this situation now where everybody is kind of unhappy. Our data engineers don't want to spend their entire time sort of writing this rudimentary business logic. Our analysts now have to wait and work with stale data potentially. And then, of course, not being able to do meaningful business insight actually becomes a roadblock for the business. So the realization I had at this point, it's kind of obvious now. Probably the folks in the room, you're all thinking, you should have recognized this earlier. Future self is that's what's telling to my past self that I should have recognized this earlier. Because every piece of software actually comes with an expiry date. When someone writes a piece of software, nobody writes it in order for it to become legacy. Everybody writes software so that it actually solves a current business problem. But there comes a time when this current piece of software becomes redundant and is not usable anymore. And the real challenge here is to understand and recognize when that expiry date is and try to anticipate that way in advance, which is, of course, easier said than done. So yeah, we're back in decision-making time mode. And if you remember from my previous few slides, we have 3 doors. There's a lion behind one, and then there are gifts behind the other 2. And so build, buy, and do nothing. Obviously, needless to say, we couldn't not do anything about this problem. Because if we did not do anything about this problem, our data engineers would have quit the company, our analysts would have quit the company would have come to a standstill, right? So clearly, we had to think about how we can solve this problem, either through a build approach or through a buy approach, or maybe a combination of both. So at that time, around 2014-ish, there was a big resurgence of streaming in the industry, where streaming here refers to processing events as they happen in real time and transporting events as they happen in real time. This is not fundamentally a new concept. I think it's existed in the software industry and in other heavy industries like for a very, very long time. But around this time, there was a resurgence of new technologies that actually a lot of the companies like Yelp were also facing at that time, the challenges that they were facing. And these technologies were actually helpful in solving those problems, and I'll come to that a little bit later. So we started looking into streaming as a solution for this problem. And so we asked ourselves the same three questions, which is, what are the out-of-the-box solutions that will work for us? And how much do they cost, not just now, but over the next 6 months, 1 year, 3 years, and so on? And can we build something better, faster, and cheaper? And this was a really hard decision to take because when you're moving your entire data infrastructure from batching to streaming, there's a lot of variables that need to change, and it's a pretty expensive migration. So we had to think really deeply about the solution that we wanted to go with. And so we sort of came up with this cost matrix because everybody loves matrices and colors and high, medium, low bars. So essentially, there were 3 different solutions. One is a commercial product. So these are things like Amazon Kinesis or any other product that exists in that space, an open source platform, or we could build something entirely on our own. And so I'll go through these costs. Some of them are obvious, some of them are a little non-obvious. The first one, of course, is the initial acquisition cost. So as you could understand, probably that the initial acquisition cost for a commercial product is going to be very high because a commercial product by definition is a profit-making enterprise, and they probably will charge you a lot of money for what they're selling. Whereas an open source platform or something that you build entirely on your own is probably cheaper and potentially even free. The recurring cost of running the infrastructure could roughly be the same depending on the kind of technologies that you're using. The setup cost for a commercial product is actually very, very low because you're paying money to acquire the product, and the setup typically tends to be easy because you're just integrating with APIs and so on. Whereas if you're building something on your own, that's going to be pretty costly. And the maintenance cost in terms of the amount of time spent maintaining it is probably the lowest for a commercial product because they're responsible for bug fixing, security patches, rolling out upgrades, and so on. But if you build something entirely on your own, you have to manage all of that stuff. So these are like 4 obvious costs. The next 2, which I personally find very, very interesting, and a lot of this was like hindsight for me, which is the first one is around flexibility. In a company like Yelp, where we are customer-facing and web-facing, the mode of the business changes very rapidly, and our business strategy changes very rapidly. So it's really, really important for the infrastructure to be nimble and agile to adapt to that. And so for a commercial product, the cost of inflexibility is actually pretty high because you don't control what the software offers. And so you will be at the mercy of this other company to build things that you want them to build. Whereas for something that you're building entirely on your own or an open source software, it's probably much cheaper because you control it. And the second important thing here is what I call cost in terms of developer unhappiness, which is how unhappy are your developers going to be if you go with any of these different approaches. It's probably medium to low for most things, assuming that the commercial product that you buy is actually easy to work with. But needless to say, probably the open source platform here beats everything because who doesn't want to work on an open source platform, right? Yes?
You talked about the expiration date and anticipating it, and I don't see it on this matrix. How did you guys think about that?
So that's a great question for those of you who couldn't hear. So the question was, how did we anticipate expiration date for this particular piece of technology? The answer is we couldn't, and we didn't. And it was a lot of like hindsight for us because we were in a position where things were not working, and then we were like, hey, we have to scramble to change things. So yeah, have I learned a lot from this experience? Yes, and hopefully be able to predict better. But these predictions are also very hard because the nature of the business also changes very rapidly. Sort of a nebulous answer to your question, but it is the truth of the matter. So yeah, so we settled into this build versus buy kind of trade-off again, and what we decided to do was invest in Kafka, which turned out to be a new hope for us. Aha, science fiction puns. And Kafka was really great at that point because it was an open source platform that the industry was very excited about, and engineers on my team, including myself, were very excited about. And it had the potential to solve the problem at hand. So we invested in that and went ahead with that. But the question you might be asking right now is, were we 100% sure that this was actually going to work? Well, the honest answer is that we weren't. Things could go catastrophically wrong in many different ways. But the thing that informed us to move along this path was through what I call sort of more speculative hedges or speculative bets. And the thing that enabled us to make those speculative bets were sort of answering these 4 questions here, which is there a prototype that actually solves a business problem using this new solution? The answer was yes, because we spent a couple of months building what we call a tracer bullet project, which is basically building the entire thing from end to end, but in a very hacky, quick way, just to assess viability of whether this is going to fit in our ecosystem, going to fit with our product. And that worked. And then we did some projections around what our data growth will look like in terms of message ingress rate and message processing rate. And we figured that, hey, this Kafka actually scales for that and will work for us. The next question was, how does industry adoption look like for this? And this was very promising for us because back then, LinkedIn was a huge adopter of Kafka. Kafka was built within LinkedIn. And a lot of companies like Yelp operating at Yelp scale were starting to invest in that. So that was promising. And the third thing was who was promoting and backing this platform. There were also positive trends in the industry there with, as I mentioned earlier, companies like LinkedIn promoting that. And the open source community around this was also very active. That was right about the time when Kafka branched out into its sort of own parent company called Confluent, and Confluent was creating this nice community of developers around this. So all of this gave us a lot of promise that this technology will not get abandoned and is something that the industry is going to support going forward in the future. So at this point, everyone's very optimistic. Data engineers like me are very excited to build this innovative infrastructure platform. Analysts are excited by the prospect of getting real-time data. And the business is very excited by the prospect of more informed business decisions. So I think time to go. Everything's done. Everything's great. Future looks great. Well, that's not really true. Even though we've built a lot of cool stuff on top of this, and we've open sourced a lot of stuff as well. Here's a list of all the blog posts that we wrote. I'm not going to spend too much time on this, but what I wanted to talk about is what went wrong. And the thing that went wrong here is not necessarily the technical solution. I think the technical solution is actually working really well, and we're building really cool stuff even as I speak right now. But the problem was there's an elephant in the room that we need to address here that we haven't talked about yet. And the elephant in the room is migrations. Now, we can roll out any new fancy infrastructure that works, but all of your existing internal customers who are using your old infrastructure need to be migrated to this new infrastructure, which is incredibly hard. And if you're thinking migrations are hard, you're wrong, because they're very, 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 very hard, as I found out through experience. And nothing captures this really well than this infographic from businessillustrator.com. And I was looking at this and I realized that a lot of what the product adoption curve, and there's a lot of references on the internet about product adoption curves, a lot of that actually directly applies to infrastructure migrations. Because at the start, you have a bunch of innovators who are really excited about the new infrastructure, and they're like, hey, we're going to migrate over, this looks great. And then you have a bunch of early adopters who are cashing in on the hype, and they're like, oh, I know this other team just migrated. They're very happy about it, so we're going to migrate, and we're going to be very happy about it. But then you end up with this big chasm, which has sharks and piranhas and other dangerous, deadly things. And then once you overcome that, you have your early majority and your late majority. And in the end, there will be groups of teams or people who simply will not like to migrate. For various different reasons, and it's important to sort of address the migrations in each phase differently and strategically. And so we did a lot of things right, we did a lot of things wrong, but in the end, we learned a lot of lessons from this experience, which I'll try to summarize next. The first important thing is choosing your early adopters very, very wisely. I think the best solution here, in hindsight, was to pick pick use cases that have zero expectations. Because for people who have zero expectations, if things go really well, they're going to be happy. They'll be like, oh, yeah, this got fixed. This looks great. But if things don't go that well, then they're going to go, oh, well, it doesn't matter. It didn't work that well. So you can iterate on that and fix your bugs and move forward. But if you try to migrate a critical business use case or someone who has high expectations from this new infrastructure, if things go wrong, they're not going to be happy about it. And worse, you're going to lose their trust. And with everything in life, like in relationships, if you lose trust, it's incredibly hard to gain that back. And that's true with software as well. Once you're past that stage, I think it's really important to manage expectations with the early majority. And what I mean by that is communicating very clearly what your system's limitations are, what are the new features it's supporting, what are the old features it's not supporting, and being really transparent about the problems that you're facing and how you want to fix them. And again, like if you think you're communicating enough, chances are that you're not communicating enough. So over-communicate. It never hurts to over-communicate. This is me just telling myself that I should keep over-communicating, because if I don't over-communicate, people don't get the message. Sorry, that was a little bit too subtle. I think the next one is once you have your early adopters and your early majority, it's important to retrospect at that point with the entire team to kind of figure out like what were the pain points in the migration, what were things that were manual work that people had to do, what are things that could be automated, and really spending the time building tooling to make the adoption for the rest of the people much easier. Because why would you want your fellow developers to suffer if you know the solution to their suffering? And of course, the last piece is managing the laggards. Laggards is a very harsh term here. I debated about whether to use this phrase here or not. But I went with it because I think it ties back into the illustration earlier. But there are always like teams or use cases who are hesitant to migrate to the new infrastructure. And there might be because of a multiple of reasons, right? It could be because your software actually doesn't support the use case that they need. Which is a real issue, and you could actually fix that. Or it could be because just some irrational fear, right? Or it could be because they have some other business priorities and they're not able to communicate that well. Whatever be the reason, I think it's really important to understand that reason. And then this is where you can use the help of your upper management to convince teams to move across. So convincing can be making sure that this is part of the other team's objectives and priorities and OKRs if you follow that format, and so on. And other forms of convincing that I will leave to your imagination. So that's all I had, and a quick sort of takeaway from what I've talked so far. So the three questions here are the what, which is figuring out your buy versus build strategy. This could be very different for you based on at what stage your company is in, your organization is in. For us, what it sort of ended up being was buy what you can and build the rest. The next important thing is anticipating the expiry date of the infrastructure you manage. It's really, really hard to do, but just having that mindset that the thing that you're building is going to die out some point, and working towards that can be very crucial. And of course, lastly, thinking very deeply about migration costs and make sure that before you commit to an infrastructure rollout, make sure you have a migration plan in place, especially things around sort of the softer side of what are other teams' priorities and what do developers and analysts feel about this change, and sort of managing those emotions and expectations are really, really important, because if they're not managed, they'll blow up in your face, as they did for me at some point. So yeah, that's all I had. And so if any of this was exciting to you and you were like, oh, this looks really cool and I want to work with this team, or maybe you were like, this guy doesn't know what he's talking about, I could do better. Either case, come talk to me. We're hiring. We're looking for folks to join the crew at Yelp, as I'm sufficiently branded here. Yeah, that's all I had. I'll leave you all with this slide with some links that you can check out later. But yeah, thank you very much for your patience and attention and listening to me ramble for the past 30 minutes or so.
I don't know if we have a mic. Oh, we do have a mic.
Oh.
We have some questions.
Hello. So it's interesting that you picked Kafka for your event messaging streaming solution, but you didn't mention any other types of event messaging streaming solutions. Did you look at simpler or more established things like using AWS SNS SQS for your streaming, or did you look for things like RabbitMQ? If not, why not? So on.
Yeah, that's a great question. I think the three main contenders for us were Kafka, Kinesis, and SQS. SQS is something that we still use at Yelp. We use it for a more event-based queuing system, which is different from streaming. They're fundamentally very similar, but the different use cases that we use them in are, for something like Kafka, we use it for replication use cases, where we are taking data from MySQL, Cassandra, Elasticsearch, putting it into MySQL, Cassandra, Elasticsearch really, really quickly. Whereas for something like SQS, we are using it for if you have a web service that needs to stage something that some other web service needs to pick up at a later point in time, we use SQS for that. Presumably, Kafka could replace that as well at some point, and that's something that we are looking into. But the difference between Kafka and Kinesis was Kinesis at that point was very expensive for us. And we just chose to go with an open source platform. And we figured there was an opportunity to actually hire more engineers, make sure engineers are happy, and it also solves a business problem. So I think there's a trade-off there on the developer happiness front as well, which played into our decision-making process. Would we have done things differently if we had the choice to change it today? Probably yes, because at this point, Kafka is actually very well established. And if I go back to the blog post links that we had here, so a lot of these stuff we built before Confluent and Kafka rolled out support for this. So if we were to build this now, probably we might not have built all of this stuff, and we would have used existing things off the shelf. But yeah, in a nutshell, to summarize your question, we ended up choosing Kafka because it was working for us, and it seemed really, it's kind of weird for me to say this, but it was really cool for us to use an open source platform and embrace that. And Yelp uses a lot of open source stuff, and we wanted to sort of continue that tradition. So that's probably how I would honestly answer that question.
Cool.
Another question?
Yeah, question. For your analytics database, are you still using Redshift for that?
Yeah, so that's a great question. We're actually hitting scaling limits on Redshift right now.
And because we're at the early stages of our adventure for machine learning and whatnot, and we're selecting as a data lake, we're leaning towards Hortonworks' distribution of Hadoop. And what are your thoughts on those data lakes that should we go S3?
Yeah, that's a great question. That's actually something we are actively discussing right now. The reason why we're hitting scaling limits on Redshift is we are sort of entering in the situation where we have silos of Redshift clusters, because you cannot have all of your business data in one Redshift cluster, because Redshift has limitations like the number of concurrent queries you can run on it. And so we had to spread it across multiple Redshift clusters. But if you have that, you can't join data across Redshift clusters, because that's not a feature that's currently supported. So what we are moving towards is a world of a data lake, as the industry calls it. And we're using S3 for that. And the reason we're using S3 is we're pretty much bought into the AWS ecosystem. And it's very cheap for us to add another Amazon functionality into something that we're already using. And Amazon has these two, new solutions called Athena and Spectrum, which integrate really well with the stuff that we already have. So the flexibility cost for us is very, very low to do that.
Okay, we have time for a couple more questions.
Hey there. So one of the things that you mentioned were the transition. Well, you sort of mentioned transitioning from a monolith to the microservices architecture, and how your analytic queries changed in that regard. And you mentioned this term called organizational scalability, which I guess is kind of like all the sort of software that surrounds like data consumption. So for companies that may not have the data scaling or volume issues that you have, but want to get started on sort of organizational scalability, from monolith to just any solution, what kind of things would you recommend to get started on? Like, is it like data warehousing, or maybe like just having some sort of streaming pipeline with like CDC or something like that?
That's a fantastic question. I think, trying to collect my thoughts here, I think it really depends on what business goals that you're trying to hit. Let's say if you're a small company and you want to iterate on your product really quickly and you want to make quick business decisions, you probably don't want to spend a lot of time building a comprehensive data pipeline, and you want to put together something that's very quick and enables these decisions. And so the simplest thing would be using a bunch of out-of-the-box solutions, like taking Redshift or taking Google Analytics as your data store, and then piping it through like SQS or Kinesis or something that you can just like plug and play really, really quickly, because that's going to be the fastest to get started. And then as your company grows, I think that's when probably have to think about how to balance the cost of these infrastructures, because they're going to be very expensive over time, and maybe sort of rip apart some of those and build your own systems. So that would be my advice, or not sure if it's great advice, but that would be my advice.
Hi, how's it going? So my company actually moved from streaming to batch processing, ironically. So I wanted to ask you again, can you kind of elaborate on what are some of the problems that you saw with batch processing, and can you just like give me like a concrete example?
Yeah. So one of the problems with batch processing for us was, as I said before, actually organizational problems, because in a batch processing world, in order to move data from one place to another, you would have to write a new batch every single time. And another problem, which I sort of alluded to, but I didn't have the time to cover, is that when we wrote our initial batching system, a lot of the business logic was embedded into this batching system. And so the problem with that is, as you scale the number of data sources, you have to follow this pattern because users are used to this pattern, and you have to encode your business logic into these batches. And that becomes really hard because the number of batches just increases. And so with the streaming solution, we sort of discarded all of that and said, hey, we're going to use streaming as a way for us to replicate data, and we're going to push ownership of business logic to the teams that own the data. So instead of having a centralized team that does all of this, we're moving towards a distributed way. Now, one could argue that we could also have achieved this with batch. Potentially, yes. But I think we wouldn't have been able to solve the data everywhere solution of like replicating everything everywhere, which is very, very hard to do in a batching kind of a world.
I guess my question is doing with when you switch over to microservices, how you end up doing with data consistency. So now you're doing streaming. If the microservices has incorrect data, how do you backfill? You lost the historical data and all that.
Yep, that's a very, very real problem.
You're having more than one microservices.
Yep.
The 40 tables you ingest in turns to 100 and something other microservices.
Yep. That's a great question, and it's a very real problem that we face. And the way we are sort of tackling that problem is systematically building auditing systems on everything that we build. So for example, the data pipeline that we've built on top of Kafka has a piece that extracts data from MySQL and publishes to Kafka. And there's a piece that extracts data from Kafka and publishes to Redshift, let's say. And when we built these systems, we also built auditors for them. So auditors that sample data to check for data corruption, and then auditors that can do sort of full message comparisons, which are much more slower and harder to run. So I don't think there's a silver bullet solution for this, but it's really investing in your auditing systems to make sure that they can tell you when things go wrong, because it's not a question of if things go wrong, it's a question of when. They will always go wrong. So I think the better solution to approach that problem, in my opinion, is build auditing systems that can tell you when things go wrong so that you can have mitigation play. Yes, it is hard to capture the window of time, but Kafka allows APIs like you can check message offsets, compare message offsets, and so on. But it is a hard problem.
So thank you for your talk today. That was really enlightening and informative. And we're going to wrap it up so that people have time if they want to change rooms. Cool. Thank you, Sri.
Yeah,
That was a
thanks.
great talk.